Alright, so the vocabulary words for today are angle, angle, side, angle, Pythagorean theorem, and HL. We'll find out what HL stands for. Our notes are titled as such. So the first vocab word is angle, angle, side. Angle, angle, side, or AAS, is basically saying if you have two triangles, to prove that they are congruent, you need two angles and then a side. So it has to be the one that's not included in there. So if it were this side right here, it would be A, angle, side, and then angle. So as you go along, for you to understand it, trace what you have on the triangle. So if we first have an angle, then we have another angle, then we have the side. So that is angle, angle, side. And that corresponds with this angle, angle, and then side. Triangle ABC would be congruent to triangle. A is the one with nothing, B has one angle congruent mark, and C technically has two tick marks. So that would be D, E, and F. The next vocab word is ASA, which stands for angle, side, angle. So this time it has to be the included side. So you have two angles and the included side. If they're congruent to the other corresponding parts of the other triangle, then those two are congruent. So this time I have two angles, like before, except the side has to be in between them. So I have angle, side, and then angle. I always go and copy it down as I see it. As I see it, I have ASA, and as I see it over here, I have ASA as well. To write our congruence statement, triangle ABC is congruent to triangle, same thing, D, E, and F. Before we go on to the next vocab word one, which some of you already know it, but I'd rather have it out in statement, it's the Pythagorean theorem. The Pythagorean theorem is the famous a squared plus b squared equals c squared, where C has to be the hypotenuse. So in this picture, C is the hypotenuse, and A and B represent the legs. So the other sides, which are also known as legs, so I'm going to put that there. They're sometimes called legs. It doesn't matter which one it goes. So I could make this one my A and this one my B, or I could flip-flop it, and it doesn't matter. You can make this one your A and this one your B. That is okay. The only thing that you really have to understand is that opposite the right angle, so if this is my right angle, on the opposite side, that's my hypotenuse. So C, this leg, or this side of the triangle, does not touch my right angle. So this blue line right here does not touch my box. And that's how you know that is the hypotenuse. So doing a quick example for Pythagorean theorem, I'm trying to find the missing side, so let's say I'm trying to find B. So 4 squared plus B squared equals 5 squared. Subtract 16 from both sides. Take the square root. There's no such thing as a negative length on a triangle, so B is positive 3. With Pythagorean theorem, that will help us define the next vocabulary word. So the next vocab word is HL. HL stands for hypotenuse leg. So hypotenuse and leg. And this theorem basically says if you have a hypotenuse and a leg of one triangle congruent to the hypotenuse and the leg of another right triangle, then those triangles are congruent. Here is the important part. Here's why. If, for example, we had, I don't know, 3 and 5, and since they are congruent over here, that's 3 and 5. You could do Pythagorean theorem. So you could do a squared plus b squared equals c squared, and you'll find out that this is 4. And you could do the same thing on this side, yada, 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 yada. Oh, guess what? That's also 4. The whole purpose of HL is so that you do not have to do Pythagorean theorem. So when you look at these, you don't have to know the lengths. They didn't even give it to you. Since they didn't even give you the measurements, but you know that it is a right triangle, you will automatically assume that these two sides are congruent. Since these two sides are congruent, you technically could do side, 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 which we've already done before. Here's just a shortcut. If it's a right triangle, no bother. The only important piece, and I'm going to tell you now, it must be a right triangle. Or else, of course, it doesn't have a hypotenuse. So check to make sure. Is it a right triangle? Great. Do I have a hypotenuse? Great. Then technically you have a side, you have another side, and you can use side, side, side by doing Pythagorean theorem to find the other one. Not necessary though in this case. So for each of these, the question is, are the two triangles congruent and how? We're going to leave number 4 blank, just so you know, box 4 will be blank. So in these squares, let's look at the two triangles. So first on number 1, I technically have a parallelogram. These two sides are parallel, PRS and PQ. This little angle right here is congruent to this one. I only have one angle mark. What's missing? Well, you could always say a segment is congruent to himself, and so I can say that. So that's one thing. However, remember, if you have two parallel lines cut by a transversal, alternate interior angles are congruent. So these two angles are congruent. So you could always add those marks. Now I have two triangles congruent. I have PQR is congruent to triangle S. Q has the red marks, so I have to say R and then Q. By what? What did I use to make these triangles congruent? Let's trace over what I've got so far. So far I have, on one triangle I have an angle, a side, and then an angle. Let's verify with the other one. I have the blue angle, this side, and then this angle. So yeah, that is angle, side, angle. Number two, the only information that I gave you was that RN bisects angle ERV. RN is an angle bisector. It cut the angle into two congruent parts. So the congruent mark that I can make is this angle and this angle. So far I have two angles. So it could either be angle, angle, side, or angle, side, angle. What's missing though? The only tick mark that I can add is that segment is congruent to himself. And the only one that the two triangles share is RN. So since N is congruent to RN, I can then say triangle ERN is congruent to triangle, E had the red mark, so VRN. And that was by how? So what did I use? So let's trace over what I've got. So I have an angle, I have another angle, and then the side. Angle, angle, side. So that makes angle, angle, side. And last example, you have the following information. AK is perpendicular to JN. So what marking I can make is, since AK, this segment is perpendicular to JN, perpendicular means it makes right angles. So I can make a little right angle symbol here. If you wanted to put it on the other side, that's fine too. So what does that make? I only have a side, and technically I have an angle, the right angle. The only one you could always add is a congruent to himself or like parallel lines. So I know that AK is congruent to himself. So what I'm going to do is I'm going to put the little tick marks on AK. If you look at this, I have a side, and an angle. That won't really help me because that's not, that's ASS, which spells bad words. No bad words in my class. However, I do have a right triangle since this is a right triangle. So yes, it's a right triangle. So check. And do I have a hypotenuse congruent to another hypotenuse? Yes. Do I have a leg congruent to a leg? Technically, yeah, a leg congruent to himself. So check. Since I have an H and an L, these are congruent by HL. So triangle blah 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 is congruent to triangle blah 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 by HL. Let's figure that out. So if I do JAK, that's the top triangle, he's congruent to NAK.